Okay, so we just completed our unit circle, so now we're going to find the terminal points determined by each of the numbers t, which are our length around the unit circle. So for negative pi over 4, we are going to add 2 pi to this so that we have a value in between 0 and 2 pi. And when we do that, if I 4 in the denominator, this becomes an 8. So I get 7 pi over 4. So now I have a value that is on my unit circle, and you can look at your unit circle and know that 7 pi over 4 has the values, or the terminal point, root 2 over 2, comma negative root 2 over 2. Eight pi over 3 is actually greater than 2 pi, so we're going to subtract 2 pi from it, find a common denominator, and we get 2 pi over 3. 2 pi over 3 is on my unit circle in the second quadrant, and that terminal point is negative 1/2, comma root 3 over 2. And our last example is negative. It's a negative value, so we're going to add 2 pi, comma denominator, and we get 7 pi over 6. And that's in the third quadrant, and that terminal point is negative root 3 over 2, comma negative 1/2. So I got all these values from the unit circle that we just completed. Okay, so the reference number is the acute angle formed by the terminal side and the x-axis. So we've done reference angles before, so t bar equals our reference number. So find the reference angle for each of the real number t. So if we go 5 pi over 6 across, then we start at the x-axis and we end about right here. Okay, so this is 5 pi over 6. So my reference angle is right here. And this reference angle is pi minus 5 pi over 6. So this is a little bit of review. And when you subtract pi minus 5 pi over 6, you get a reference angle of pi over 6. So remember, all of our reference angles are going to be angles that lie in the first quadrant because they're the acute angles, so they're in between 0 and 90 degrees. So for the second example, 4 pi over 3, based off my unit circle, is about right here. So this whole angle around is represented by 4 pi over 3. So my reference angle is going to be right here. So since 4 pi over 3 is greater than that angle, I do 4 pi over 3 minus pi. And when I subtract, I get pi over 3. And my last example is, my last example on this page that you can see is 7 pi over 4, which is about right here. So almost all the way around is represented by 7 pi over 4. So my reference angle is right here. And to get that, I have to subtract it from 2 pi. So my reference angle is pi over 4. Problem D is really nice because it's pi over 3, which is about right here, and since it lies in the first quadrant, is its own reference angle. Okay, so 15 pi over 4 is going to be greater than 2 pi. Now, we still need to be able to graph 15 pi over 4. So what I'm going to do first is figure out my terminal value So I'm going to do 15 pi over 4, and I am going to subtract 2 pi from it in hopes that I can find a value that is in between 0 and 2 pi. So when I do that, I get 7 pi over 4. So what does that mean? That means that I'm going to end at 7 pi over 4 is on our unit circle. It's in the 4th quadrant. But again, like I said, we need to graph the whole value of t, which is 15 pi over 4. So you can't just graph 7 pi over 4 because that's not the full t value. So we know that 15 pi over 4 is at least all the way around, and because that's 2 pi. So since we subtracted 2 pi from it, we were then left with 7 pi over 4, which goes from the x-axis all the way right here in the middle. So remember, we go counterclockwise in that direction because it is a positive value. And so now we can now talk about our reference angle. So we do 2 pi minus 7 pi over 4 now, because all I want to compare is the distance from that blue line to this new, to all the way around, which is a 2 pi, and we get a reference angle of pi over 4. So the thing about that is that you have to know that what we graphed here in blue is represented by this whole t value. And sometimes we have students that figure out the value then that lies within the unit circle 1 revolution, which is 7 pi over 4, but then that's all they graph. But you have to go all the way around and then an additional 7 pi over 4. So for problem F, it looks a little odd because there's no pi, but that's okay. 2 pi is greater than 5.8 because 2 pi is 2 times 3.4 blah blah blah, or 1/4 blah blah blah. So that's at least 6 something. So that puts us in the 4th quadrant, let's say about here. So all the way around is about 5.8. So to find the reference angle, we are going to do 2 pi minus 5.8. And in this case, we are going to actually use pi, 2 times pi, and then subtract it, and we get about 0.48 as our reference angle. So don't be alarmed if there's no pi there. It still is our reference angle because it's in between 0 and pi over 2. And since this lies in there, then we are good and we know it's our reference angle. Okay, so we are going to continue to do practically the same thing, but then I want to find the terminal point. So you have to tell me the point where it ends, not just the reference angle. But to do that, we need to find the reference angle first. Okay, so 11 pi over 6 ends about right here. So this blue angle is 11 pi over 6. So we need to find the reference angle. So my reference angle is going to be from 2 pi. So 2 pi minus 11 pi over 6 equals pi over 6. So that's my reference angle. So again, what's graphed in blue is represented of the t value. So why do we find the reference angle? Well, that reference angle that's in pink, it's going to help us figure out the terminal point. So there's 2 ways you can do this. The first thought process is, okay, well, just go to 11 pi over 6 on your unit circle, and since it's all filled in, tell me what point is at the end point. And that would be root 3 over 2, comma, negative 1/2. So that's my p-value right here. Root 3 over 2, comma, negative 1/2. It's in the 4th quadrant. Or what you can do, since on the quiz or on quizzes and tests, you're going to get a unit circle that only has the first quadrant written in. The points are only in the first quadrant. So what you can do then is find the reference angle like we did in pink, which is pi over 6. So you know that the reference angle terminal points is going to be the same value as the given 11 pi over 6. The only thing then you need to consider is, are they positive or negative? So knowing based off of the graph in blue that it ends in the fourth quadrant, on your unit circle, you go to pi over 6, which is root 3 over 2, comma 1/2, and then you know that those are your points, which we already have written, but then because we end in the fourth quadrant, we know that the x value is positive, which it is, and then we have to go down, which means that the y value is negative. So that's why it's root 3 over 2, comma negative 1/2. So there's two ways that you can do it, but you still need to be able to find the reference angle. So I'll walk you through this again. So 5 pi over 4 ends in my third quadrant. So if you have a unit circle that is completely filled in, we can skip all the way down to the point, look at 5 pi over 4 and say, okay, that is negative root 2 over 2, comma negative root 2 over 2. What you also do, or can do, is say, okay, let's find the reference angle. So that's going to be 5 over 4 minus pi, which gives me pi over 4. So now that I know that that's my reference angle, I look at my chart, and at pi over 4 in the first quadrant, I have root 2 over 2, comma root 2 over 2. So I write those points down here, and then I have to say, but it's in the third quadrant, so it's a negative, comma, a negative value. Number 3, 2 pi over 3 ends in the second quadrant. So if I did the reference angle first, I would subtract pi minus 2 pi over 3, and I get pi over 3. So now using my reference angle in the first quadrant, pi over 3 is 1/2 and root 3 over 2. Then I need to check my signs, and since up here we're in the second quadrant, I know that that 1/2 is negative and that root 3 over 2 is positive, and that's my terminal point. So there's a couple different approaches. You can pick the one you like, but you at least should be able to fill this out and know the relationships between the terminal point and your reference angle. So try the next 3 and then see if you get what I get. Okay, so for number 4, negative 7 pi over 4, we need to go the length of 7 pi over 4, which usually in the positive direction ends in quadrant 4. But now if we're going negative, it's going to end in quadrant 1. So this is going in this direction and ending there. That is 7 pi over 4. So where does that end then? That then ends at pi over 4, and you also know that because you're going to figure out your reference angle, which in the first quadrant, since that's where you ended anyway, is pi over 4. So negative 7 pi over 4 has the same terminal point as positive pi over 4. So in the first quadrant, pi over 4 is root 2 over 2, comma root 2 over 2. All right, 10 pi over 3. 10 pi over 3 is greater than 2 pi, so I know I'm going to at least go around once. So if I subtracted 2 pi from it, it'll give me the leftover. So I know I am at least here, but then I have to keep going. And if I did that, common denominators, I'm going to get 4 pi over 3. So that's how much further I need to continue this swirl graph, okay? And 4 pi over 3 ends here in the third quadrant, so I'm going to swirl over and end here. This is where I end. So that is the full graph of 10 pi over 3. So to find that point, though, you need to use the reference angle. So you're going to do 4 pi over 3 minus pi, and you get pi over 3. So if I use that reference angle, then pi over 3 in the first quadrant has the points 1/2, comma, root 3 over 2. But in my graph, 10 pi over 3 ends in the third quadrant, which means they are both negative. Negative 19 pi over 6. Okay, so since it's negative, I'm going to add 2 pi to it. And when I do that, I still get negative 7 pi over 6. So I have to add another 2 pi to it. And when I do that, I get 5 pi over 6. Okay, so what does this all mean? This means since I need to add 2 pi to it, I'm going to go 2 pi twice. So I'm going to actually graph a swirl, if you will, that represents 4 pi. Then what's left over is an extra 5 pi over 6. And you have your unit circle so you know how long or how far around you go to get 5 pi over 6. It's in the second quadrant. However, you have to go in the negative direction. Okay, so we're actually going to go back a step. I want to go back, and instead of making it positive, I want to just focus on making it a value that is in the unit circle. And negative 7 pi over 6 is on the unit circle. We just need to go in the opposite direction. So that means we are going to graph 2 pi in the negative direction, which is right there, and then negative 7 pi over 6 is going to end right here, which would be essentially 5 pi over 6. Okay, so what's in pink represents negative 19 pi over 6. So to find our reference angle, we do pi minus, now this point though in positive is 5 pi over 6. So that point, so negative 7 pi over 6 revolves all the way around to the value that is a positive 5 pi over 6, which gives you a reference angle of pi over 6. My pi over 6 values are root 3 over 2, comma 1/2. Since I ended in the second quadrant, then my first value needs to be negative.